Hello, in this video I'm going to be showing you how to derive the quotient rule in differentiation using an alternative method. Now, if you haven't watched my previous video about the product rule, I would recommend watching it before watching this video, as you'll understand why I came up with these definitions at the top of this screen. I've left the link to my previous video below this video, so if you want to watch it, click the link below this video that will take you there. So, deriving the quotient rule. In this case, the function of x is going to be gx over hx. This means that the function of x plus change in x is going to be gx plus change in x over hx plus change in x. Now, if these two statements are true, then this over here is going to be true. And for this fraction over here, what you see in brackets is the numerator. This goes on top of change in x. So like previously, when we were deriving the product rule, the derivative of the function of x is going to be the limit as change in x approaches 0 of the function of x plus change in x minus the function of x over change in x. Now, because we've identified this up here, it means we can change this over here to this down here, okay? And this is what we're going to use to get the quotient rule. So using algebraic rules, we can transform what's inside these brackets into this over here, okay? And if we do that, we can then transform this up here into this down here, okay? Now, of course, you can watch this video again if you want to see how it's done and do it yourself. But to make this video shorter, I'm going to go through things quite quickly. So at the moment, we're over here. And what we're going to do is transform gx plus change in x and hx plus change in x. Also, the hx plus change in x over here. We are going to use the definitions up here to make those transformations. If we transform this equation over here, what we get is this over here below, okay? And if we expand, what we get is this. And hx and gx over here and over here, because this is negative, cancel each other out. So what we're left with is this over here. Now let's tidy this up, okay? What we're going to do is multiply 1 over change in x by this numerator over here. So we get this in brackets above this over here, okay? Which is very useful. And from this point over here, we're ready to get the quotient rule. This is because as change in x approaches 0, change in hx approaches 0, change in gx over change in x approaches the derivative of gx, change in hx over change in x approaches the derivative of hx, okay? So that means this change in hx over here disappears, okay? And this over here becomes the derivative of gx, and this over here becomes the derivative of hx. So what we are left with is this over here, okay? And we call this the quotient rule. Now you can find the workings to this video on mathematics.proofs on Instagram. Search for my latest post over here and you'll get the workings. For more mathematics proofs, make sure you're subscribed to this channel. Thanks for watching, and I'll see you in my next video.